Okay, so this is going to be the final lesson, lesson 5 for our radical section. I already recorded this video once and then I made a goofy error on there. I'm not going to get into that one, a little embarrassing. I do have the first 3 examples up here. They're fairly straightforward and simple, so I worked through in advance just so I don't have to eat up too much time here. Just the whole point of why did we do these ones first. We have this one here. Again, we have to remember we need to do a check with our work, right? So after you solve for this, well, straightforward, square root of x equals 4. You square both sides, you find x is 16, you check your work. That must be done for all questions. With example 2, what this one introduced us to, again, was we can use a rational exponent, which is a fractional exponent, where the numerator of that exponent is going to be a power, the denominator is going to be the index of a radical. So these two, so the square root of x cubed and x to the power of 3 over 2, these are identical. So again, because this is a radical, it's telling us in the question originally that this is a radical, so that means the number coming out of there must be a positive again, which is going to lead us into, as we solve through this, when we get to the final answer, and we do our check on this one, we find that x is equal to the 4 to the power of 3 over 2 is going to come up to a positive 8. So our 8 equals negative 8. It's not going to work. So although the math worked originally, our check found what is known as an extraneous root, which means just because our answers work, we still need to check to make sure that there isn't something else going on with the whole positive and negative thing that's coming out of our radicals. Our third example, again, is fairly straightforward. The big thing I want to see out of this one is notice that when I did the check down here, I did not do any algebra in my check, right? We found that x is equal to 64, so when I'm doing my check, I'm not moving the 4 to the other side, right? We have values, all bed mass on the left side, all bed mass on the right side. We keep the left side and right side the same. No algebra, adding 8 to both sides, dividing both sides by 2. That does not happen. You solve for what each side equals, and you go from there. So that one, we're going to leave it as the cube root of 64 minus 4 equals 0. That means 4 minus 4 equals 0, 0 equals 0, check. We do, in fact, have a correct answer. So example 1, straightforward. Example 2, an extraneous root. And example 3 is going to have a successful answer in the cube root format. Again, there was a check done for every question. I'm going to reset the board and we will look at the more complex equations for the next couple of examples. So here we have example 4, which is x plus 2 times the square root of x minus 3 equals 6. Now that we learned the minor parts of this, it's just taking this to a whole new level. We just have a little more work to do. Same exact procedures we're going to follow. The one thing that we will introduce now also is, along with those extraneous roots we got to check for, we should also check for restrictions, right? We know that radicals have to be positive values if it's an even index. So we know that the x minus 3 has to be a positive value. That is a restriction we can do, and that should be the first thing we do. Right, so x minus 3 is under the radical sign, so we know that x minus 3 must be greater than or equal to 0, but we can't leave it at that. We got to solve for x in this context. So x must be greater than or equal to 3. We found our restriction. Now we can go and continue our work. I have the radical. I want to square to get rid of it, but if I square the left side now, it's going to become an x squared plus, and it's going to keep going. It's going to be ugly, so we want to isolate our radical first. And I did that by subtracting x from both sides. Now I can look at squaring this. Boom. Right, and then we can follow these steps. So 2 times the square root of x minus 3 squared, so 2 times 2 is 4, times that x minus 3. 6 minus x squared, right, this is going to be our a squared minus 2ab, or sorry, minus 2ab plus b squared kind of thing mentality. So we're looking at the 36 minus 12x plus x squared. I can simplify this a little more. So here we have our 4x minus, oh, I put minus 3. That could cause problems later. 4x minus 12, of course, distributive property. So again, now I'm trying to solve for a quadratic, right? And next for a quadratic, we learned to do this when we were doing the quadratic equations. So I'm just going to put all of my terms on one side, make this equal to 0. And I can solve for the two possible answers that way. So the 36 is going to be adding 12, so 48. That's taken care of. The minus 12x, I'm just going to subtract over minus 16x. I have this in a rational form. I'm going to rearrange just to put it in more familiar terms. Again, not necessary, but if it helps you visualize, which it does for me, I'm going to rewrite it in this ax squared plus bx plus c format. So of course then I take 12 times 4, is 48, both of them negatives. Yep, that'll work. So my two solutions are going to be when these are going to make this equation equal 0. So when x minus 12 is equal to 0, that means when x equals 12 is a possible answer. So when x minus 4 is equal to 0, this is true. So that means x equals 4 is a possible answer. So x can equal 12 or x can equal 4. I have two possible answers. With that, I got to look at, again, because there might be an extraneous root hiding here, so I do have to still check my answers. And again, I'm going to plug this x value in, and I'm not doing any algebra. My check is going to be keeping left side, keeping right side. So I'm labeling, I'm going to do the x equals 12 check first. So oh, I guess I should make sure I write down 12 plus 2. All right, so I'm going to check this. So 12 plus 2 times the square root of 9 equals 6. So 12 plus 2 times the square root of 9 is 6. So for 12 to work, then we can see that it does not work, right? If it was a subtract, if a negative 12, then perhaps, but again, that the absolute value coming out of the radical is going to cause an issue with that. So 18 equals x, so that means that 12 is an extraneous root. And I guess like one thing I could have done as well, because I would check, I did the restrictions, I should have checked that first thing, right? X is greater than or equal to 3. I got the two possible answers of 12 and 4, which are both greater than 3. So they both answers did fit the restrictions. So 12 turned out to be extraneous. Let's see if there's an answer at all, or if 4 works or not. So I'm going to check that one next. So I want to check if 4 plus 2 times the square root of 4 minus 3 equals 6. So 4 plus 2 times the square root of 1 equals 6. So if 4 plus 2 equals 6, yes it does. 6 is equal to 6, so this is in fact our answer. So that is my answer. So I have two possible answers. One was removed as an extraneous root. The other was the final and correct answer for this question. So that takes us through example 4. We got a couple more examples to do. So let me reset and we'll do example 5 next. Okay, so looking at example 5, the issue with this one, of course, is we have two radicals in here, and it's like, oh, how are we going to do this one? So there's a couple options that you might think are there, but there's only one best option, really. you might look at this and say, hey, I can square it. What if I multiply by the conjugate? What that's going to do is might clear up radicals on this side, but that would introduce radicals onto the other side. So the only thing we can do is baby steps. Let's isolate one radical, square it up, get rid of it. That should leave us with only one radical on the other side, and then we can get rid of that one by squaring up that side. So this is going to be done in 2 steps, just like I said. So we're going to have to isolate one, square it, and then isolate the remaining one, square it, and then we have an answer we can work with. Of course, because we're doing radicals, the first thing we should always do is still look at restrictions. And an interesting thing happens here as well is we're going to look at 2 restrictions. So do we give 2 restrictions? Well, let's take a look. We know that 2x plus 3 must be greater than or equal to 0. Which means 2x must be greater than, 2x must be greater than or equal to negative 3. I'm just going to make that, got ahead of myself a little. Must be greater than negative 3, which means x must be greater than or equal to negative 3/2. On the first one, we also have a second radical, where the square root, how do we do that? Where x plus 1 must be greater than or equal to 0, so x must be greater than or equal to negative 1. Now, so we have 2 restrictions, but there's an overlap, right? And that's what we're looking for, is where do they overlap? If one applies, right? Do we need to write both of these? No. If I can take the one that has the greater value, because we're going greater than, let's see. So number line, 0, right, negative 1, negative 2. So if I have one that is greater than negative 1, it has to be this way. The other one has to be greater than negative 1.5. Right, so again, if I just use the x is greater than or equal to the negative 1, then that covers both. So I don't need 2 restrictions. I only need the 1 restriction. So my final restriction for this would be x must be greater than or equal to negative 1. It incorporates the other one with it. Otherwise, let's get to solving this. So, right, I have square root of 2x plus 3 minus square root of x plus 1. Again, so I'm going to isolate one. I'm just going to add a square root of x plus 1 to both sides and go from there. So there we go. I have one of them isolated on the left side. Now I can square both sides. And this is going to be the one that's going to be, right, we can FOIL out. This is the one to watch out for. Again, the a plus b squared is going to equal a squared plus 2ab plus b squared mentality. We've done that in math. So 1 plus 2 1 plus 2 root x plus 1, square root of x plus 1 plus an x plus 1. That will be what we end up with. Now I can again isolate this variable, because this radical is to get it all alone. I can let's subtract 1, subtract 2 from both sides, subtract an x from both sides. So now I will have the x plus 1 is going to be equal to 2 times the square root of x plus 1. And again, I can go back to squaring both sides. So I end up with the x squared plus 2x plus 1 is equal to 4 times x plus 1. Stretch this out. And now I just want to get this entire quadratic equal to 0. So I'll end up with x squared minus 2x minus 3. So now I got this in a basic ABC format. So I'm looking at negative 3 and positive 1. And just like that, I can find that my answers for this must be x is going to be equal to 3 or x is equal to -1. Okay, we go back to our restrictions. X must be greater than or equal to -1. I have a -1, 3 is greater than, so these are both possible solutions. Looks like I'm going to have to check both. So what I'm going to do is just maybe pause this so I can make the video shorter, and then you'll have a magical checks done already. So just give me a moment here. And through movie magic, of course, I got the checks done, and you didn't have to sit through me, and it was good because I think I made an error in there while I was doing the original. We can check it then. X equals 3. We plug it in for the x on the left side. Right, we didn't change what the left side was and the right side was, right? The right side was originally stated to be 1, and I continued, it should be 1 all the way through. Did the math, yes, when x is 3, 1 equals 1. When x equals -1, yes, 1 equals 1. Both answers checked out, both are appropriate answers. And of course, so x can equal 3 or x can equal -1. There's 2 possible solutions for example 5. All right, let's take a look at the next one. Okay, so example 6, we're just looking at a square root of a square root now. Nothing changes here. Yes, they're within each other. It's just a matter of making sure, right? When I square the left side, right, I'm just getting rid of the outer square root, so it's going to be so now it's just 2 times the square root of x. I got rid of the outer one. The 6 did get squared to 36. The only thing here is I can square both sides now, and I can get 4 on this side and 4x. Or if I see this now, this coefficient, I can divide this 2 out of the left side and out of the right side. I can do that now and save myself a hassle. So if I divide both sides by 2, I come up with the square root of x equals 18. Again, square. And x is going to equal 324. I raced through this one real quick. I should, of course, include, I didn't do my restriction on this one. Yes, there is a restriction. X is still under radical, so x needs to be greater than or equal to 0. Yes, my answer is. Then I do the check. May as well keep consistent and use my green. So when x equals 324, so the square root of 2 times the square root of 324 should equal 6. So the square root of 2 times the square root of 324. I keep doing this all crazy. Oh, my brain hurts. 18. So 2 times 18 should equal 6, so that's the square root of 36 equals 6. So yes, x equals 6, and then that is my final correct answer. Yes, x is equal to 324. I have the restriction, I have the check, and I'm ready to move on to our final example and call this lesson done. And here we are at our example 7. So we're looking at, this is a word problem. A lot of people get a little freaked out when they have word problems, but if you take it baby steps at a time, they're not that bad, right? So they're talking about the radius is equal to the square root of the volume divided by pi times the height. They gave us an r value, they gave us a v value, now we have to go in and solve. So it's just, we have the original equation, substitute and solve. Again, we should check and see. We still have some restrictions on our variables, right? So we have under the radical sign, we have a v and we have an h. It's a v right divided by, so we know that v needs to be greater than 0. We know that h is greater than 0. So those are going to be our restrictions. So yes, those are the restrictions we have. And then we just plug and play, right? So we do have an r, so 5 equals the square root of pi h. We are solving for h, and again, we treat this as normal. We're going to square both sides. 25 equals 400 over pi h. Your example, you don't have to move, like I said, I'll talk of this after. Your example, what they do is they just, to get rid of the denominator, multiply both sides by pi h. So we end up with 25 pi height equals 400. Now we want to solve for height. We can do this by dividing out 25 pi from both sides. So you'll see that we did do an extra step. The pi we moved up here and then we moved it back down again. We don't have to do that, but sometimes it's easier just to keep it together. That's going to come personal preference. The only thing is they asked for this to be a simplified answer. They asked for it to be kept into terms of pi. So we're going to leave the pi it is. We're going to simplify the 400 over 25, which as it turns out is 16 over pi. That would be the height of this situation here. Yes, we could do a check as well. I just want to get this video done and moving. That should hopefully help you out. Let me know if you have any questions through email or phone calls. And you are good for the final lesson of our radicals, and we'll see you in the rational world.